gør jo heller ikke noget.
Plus minus.
Jeg har Phil, der kommer til at moderere det, og jeg har sagt, at hvis han synes, at der er et spændende spørgsmål, enten fra chatten, eller han selv synes, at der er et eller andet intelligent at spørge ham, så spørger han, men så er det nok et spørgsmål, han spørger om.
Og det er, der er også en chat, så dem, der sidder rundt omkring og kigger på, får spørgsmål, som vi så får tilsendt. Men ellers så er der også en session efter din præsentation og KEA's og KRISO, der er sådan en wrap-up spørgsmålssession. Og alt efter hvor meget tid, alt efter hvor meget forsinket vi er, så er der tid til spørgsmål der.
Men det var nemlig det, der var lidt mit spørgsmål. Altså det her programmet, ikke? Og så er der først Finn goddag, så kommer Jakob, så kommer der nogen her, jeg ikke lige ved, hvem er fra Holland, og så er det jo ikke en ny præsident, eller? Ved han ikke det før, eller? Nå, det er også lige meget. Så kommer Christoffer og siger noget, og så Jakke, så er der de her forskellige, de præsenterer det der studie.
Cost of Energy studie, ja.
Det kommer til at tage pænt lang tid.
Ja.
Hello, good morning. Are we ready to begin in 4 minutes?
Good morning.
Good morning.
Hi, Lisa here from Covey in Hamburg. Can you see and
Hi,
hear me well?
Lisa. Yes, we can, at least from our side. The Penthouse Hilton is the Korean host as well. So
Okay.
yes, but I just wanted to check if Korea can hear us. Korea? Penthouse Hilton, can you hear us in Copenhagen? I will just try and call them. Det tror jeg simpelthen lige.
Sure.
Ladies and gentlemen, please take your seat. We will start in 30 seconds.
Good morning, everybody, or good afternoon, depending on where in the world you're watching from. Before we begin, a short practical remark. This webinar will be recorded and you can watch it on demand after our event today. Furthermore, I would stress that today's event is being translated between Korean and English languages, so be sure you're streaming in the correct language. You can actually choose another setting by clicking on the stage on top of your screen. After those remarks, esteemed guests, speakers, and all of you who have signed up online to attend today's webinar and joining from our venue in Korea as well, my name is Finn Mortensen. I'm the Executive Director of State of Green, a public-private partnership, not-for-profit, between the Danish government and the leading business organizations in Denmark. I will act as the moderator today and make sure we get through the next couple of hours in the best possible way. Today's event is an official side event for the P4G Summit in Seoul, which is currently going on. P4G stands for Partnering for Green Growth and the Global Goals 2030, and we hope that in the name of partnerships, today's event will strengthen and deepen the already strong ties between the decision makers joining from both Denmark, Korea, and the Netherlands. The event today is entitled Offshore Wind 12 Gigawatt and Beyond, and is organized by Korea Energy Agency, the Danish Energy Agency, the Dutch Embassy in Korea, the Danish Embassy in Korea, the Confederation of Danish Industry, and State of Green, which also serves as a national platform for P4G in Denmark. We have a tight schedule, so I will ask all speakers to keep the time, and we will start with several remarks and presentations. So let's roll. Our first speaker today is Mr. Jacob Rasmussen, who is Energy and Environment Counselor at the Embassy of Denmark in Korea. Jacob, the floor is yours.
Thank you, Finn. Thank you for those words. It's very good to have you with us as an experienced moderator in Copenhagen. Excellencies, ladies and gentlemen, good morning, good afternoon. Welcome to the online participants. It's a great pleasure to take part in this only session at the P4G Seoul Summit that are purely dedicated to offshore wind. And thanks to all of you who decided to join us today to discuss this important topic. As Finn mentioned, we are here today to mark the important week of the 2021 P4G Seoul Summit. As the host of the last P4G Summit, Denmark is very happy that our Korean partners have chosen to host the P4G Summit this year. The theme of this year's summit is Inclusive Green Recovery towards Carbon Neutrality. Offshore wind plays an extremely crucial role in achieving carbon neutrality. I'm very pleased to introduce today's side event focusing on offshore wind in Korea. Last year, some of you may know that President Moon announced that Korea is aiming to be carbon neutral by 2050. In this regard, Korea, as a first step, is planning to establish 12 gigawatt of offshore wind by 2030 and expanding their renewable energy capacity to 20%. The goal of today's event is for Denmark, Korea, Netherlands, as P4G partner countries, to jointly explore possibilities for the cooperation on this matter. As demonstrated by the current P4G Summit, Denmark believes that partnerships is the way forward for a future green transition. And this week, I myself had the pleasure of witnessing a MOU signing ceremony between POSCO and Ørsted to collaborate on offshore wind and green hydrogen. And hopefully this can also be a stepping stone for more partnerships between foreign companies and Korean companies in the future. Together, we can use already existing knowledge and know-how to accelerate Korea's offshore wind target of 12 gigawatts and at the same time lower the costs. With the purpose of sharing experiences between our three P4G countries, today's event will focus on the 3 Ps: price, policy, and planning. First of all, the event will focus on price by launching the findings of a new cost of energy study in Korea. After that, we will examine policy based on 30 years of experience within offshore wind in Denmark. This will include a presentation on the Danish model of a one-stop shop and background and reasoning for screening and marine spatial planning. And lastly, we will discuss the issue of planning in Korea. And in this regard, we will explore the research and development on floating offshore wind in Korea, as well as how to create an integrated farm of offshore wind. I look very much forward to all of the presentations here today and to the future cooperation on this matter. If we go together, we can go longer. So welcome everyone to this official P4G side event, Offshore Wind Korea 12 gigawatt and beyond.
Thank you very much, Jacob, for the introductory remarks. Now it gives me great pleasure to introduce our next speaker, Ms. Hanneke Schuiling, who is Director General for Foreign Economic Relations at the Ministry of Foreign Affairs in the Netherlands. Please, Ms. Schuiling, the floor is yours.
Ladies and gentlemen, it is a pleasure to welcome you at this side event on offshore wind energy. Let me first thank the Danish Embassy, the Korean and Danish Energy Agency, the Korea Research Institute of Ships and Ocean Engineering, and the Confederation of Danish Industry for organizing this important event. It brings together governments, knowledge institutes, and businesses from our countries to discuss the latest developments on offshore wind and the opportunities for South Korea. This online event takes place against the backdrop of the P4G summit, a context in which Korea, Denmark and the Netherlands are equally strong partners. At this summit, we explore partnerships to accelerate the achievement of the Sustainable Development Goals and the Paris Climate Agreement. An excellent opportunity to exchange views on offshore wind in Korea. While the spread of the COVID-19 virus made it impossible to meet face-to-face, I think the promotion of renewable energy is just too important to wait. Because, as the International Energy Agency keeps reminding us, reaching energy and climate goals will demand a dramatic scaling up of clean energy technologies. Studies from the IEA and the International Renewable Energy Agency, ARENA, all predict a major increase in offshore wind capacity worldwide and further cost reductions. In short, the future looks bright for offshore wind, including in South Korea. However, not surprisingly, when trying to stimulate the development of wind energy farms, governments all over the world face similar challenges. For example, how to set up a tender procedure for offshore wind parks, how to mitigate the environmental impact, and how to ensure the right port facilities. Looking at today's program, I am confident that this event will provide you with new insights and ideas on how to tackle these challenges. In the Netherlands, public and private parties team up to design, develop, build and maintain offshore wind parks. Firstly, based on our long-standing experience and in-depth knowledge in offshore projects around the world, companies develop new, innovative solutions for offshore wind together. The Dutch industry excels in the installation and maintenance of wind farms. Secondly, the Dutch government oversees the whole consenting and permitting process, reducing the risk for developers significantly by providing full sets of certified offshore wind data and site studies. And thirdly, our transmission system operator TenneT takes care of the grid connections and transmission infrastructure. This integrated approach helps us to develop wind farms in an efficient and cost-effective way. And I think a similar strategy could be useful for South Korea as well, to achieve its offshore wind ambitions. I know that several Dutch companies are already very active in your country on offshore and floating wind projects, including Shell and Fugro. With innovative developments like these, there's all the more reason to work together and share experiences. A conclusion which I understand is underlined by the study done by Pondera, another Dutch company, which will be presented here today. Therefore, ladies and gentlemen, I hope this session will not be a one-off event, but will be part of a long-term cooperation between our countries. A partnership aimed at paving the way for the development of offshore wind energy in South Korea and abroad. A possible next opportunity for exchange is the masterclass on offshore wind that we organize every year in the Netherlands in October. This year's masterclass will be combined with an event on hydrogen, as this fast developing industry is closely related to offshore wind. Let me use this opportunity to invite Korean offshore wind professionals to this unique event. I look forward to our journey on offshore wind together, and I hope to meet you again in the Netherlands in October, be it online or in person. I wish you a fruitful event.
Thank you very much, Ms. Schüling, and I can only echo what you said about the bright prospect for wind. Now, the next speaker, I would like to pass the floor to Mr. Chang Seop Kim, who is the president of the Korea Energy Agency. Mr. Kim, the floor is yours.
Wow. 여러분 반갑습니다.
Hello, everyone. Great to have you all. I'm Kim Chang-seop, President of Korea Energy Agency, or KEA. Let me first extend my gratitude to the Danish Embassy to Korea, the Dutch Ministry of Foreign Affairs, and DEA for putting together this meaningful event. And allow me to also recognize the relentless hard work of everybody in Korean wind industry for their incredible contribution to the development of this industry, and as well as the Danish partners. As you all know, the world is faced with climate change in the form of extreme weather, ecosystem disruptions, and many others. And we are trying to transition ourselves from the black energy to the green energy. And Korean government, especially this current one, is putting all out efforts for this end. And Korea has set a goal to produce 20% of its energy from renewable source by 2030 under its Renewable Energy 3020 implementation plan, and to generate 12 gigawatts of offshore wind. Offshore wind power is a key energy source amongst various renewable energy sources. And in 2020, 93 gigawatts of new wind power capacity was added globally, which is a 53% jump from 2019's 60.8 gigawatts. And to accelerate the adoption of offshore wind in Korea, the Korean government is supporting the industry with site selection, as well as community acceptance in the areas for the farms to be built. We fully understand that there's a need to streamline the permitting process, which has been very complex. So to that end, the Korean government is also trying to promote a Korean version of the one-stop shop with a planned legislation of a special act for this very purpose. 2021 marks the beginning of the actual implementation of the Paris Agreement. And 2021 for P4G Seoul Summit is here to lay the very first step of this important journey together. Today's webinar, joined by Korea, Denmark, and the Netherlands, is an official P4G side event where we reaffirm ourselves the very importance of wind power as a response to climate change. In particular, Denmark has a wealth of experience in the field of offshore wind, from development of the site to operation, aided by its state-of-art technology. And I understand that to ensure speed and systematic approach to offshore wind development, Danish Energy Agency, or DEA, took the lead in the effort and has operated the one-stop shop, successfully, therefore, positioning itself as a global leader unmatched by anyone else, but together with the Netherlands. As for Korea, our offshore wind's cumulative installation capacity stands at 145 megawatts, clearly showing that we're at an infant stage. So today at this webinar, we'll be covering such topics as offshore wind power cost analysis study, one-stop shop, marine spatial planning, site selection for offshore, as well as the R&D status of the floating offshore wind technology. I hope such exchanges of information will contribute to fostering offshore industry of both countries. Government's policy supports should always go hand in hand with the industry's efforts to learn from best practices. And together, when we continue to take on the new challenges and push ourselves to the next limit, I have no doubt the future of our wind industry will be bright. KEA will do our best towards this common goal and will stand at the forefront of addressing the global climate change and achieving carbon neutrality. Once again, my deep appreciation goes out to Danish Embassy in Korea and DEA for offering this valuable chance to exchange our knowledge and experience in offshore wind in both countries. Thank you very much.
Thank you very much, Mr. Chang Seop Kim, for laying out the prospect for wind in Korea. And it was really good to hear that KEA is fully committed. And for instance, your insistence on streamlining the permitting process and looking to Denmark for the one-stop shop principle. Thank you very much. And now to the final opening remarks, which will be given by Mr. Christoffer Bøtzau, who is Director General of the Danish Energy Agency. Christoffer, the floor is yours.
Thank you very much, Finn. And good afternoon in Seoul, and good morning in the Netherlands and in Denmark. It's a great pleasure to have the opportunity to speak at this P4G side event on the important topic of offshore wind today. With the Paris Agreement and the Sustainable Development Goals, the world has set the path for global green transition to combat climate change, a path that still holds many unknowns and uncertainties. But we do know that to get there, decarbonizing our energy system will be a necessary step. Energy accounts for 2/3 of the world's carbon emissions. Offshore wind is going to play a key role in getting there, and the potential globally is huge. In Denmark, we have already come a long way with energy transition. In 2019, 47% of the Danish electricity consumption was generated by wind, a majority of it being located offshore. The first step in Denmark's green transition was taken more than 30 years ago with the world's first offshore wind farm. It has brought us to where we are today at the dawn of a new area in offshore wind development with the construction of the world's first energy islands with a total capacity of 10 gigawatt. One reason for this successful transformation has been a broad cooperation between the government, the industry, and the civil society. As an example, I would like to mention the transformation of the Danish energy company Ørsted, who throughout the last decade has undergone a transition from being mainly based on fossil fuels to being almost entirely based on renewable energy. This transformation, including learnings and recommendations, is described as a brand new report that will be published on Monday. The 3 P's being discussed today, price, policy, and planning, have been instrumental to making Denmark a market leader in offshore wind. Cost is always a challenge for the new technology entering to the market. However, through scaling, investment into research and development, a long-term planning, Denmark and Europe have been able to cut costs of offshore wind by 75% between 2014 and 2019, only 5 years. Today, offshore wind is competitive with most conventional energy sources. Policy has been an important tool in de-risking the development of offshore wind. A good example from Denmark is the one-stop shop, which my colleague Stig Uffe Petersen will be talking about later. It has streamlined the tender and permitting process and made the process much more transparent. And last but not least, long-term planning. It is essential to create a stability that allows building these massive infrastructure projects that takes years and huge investment to compete. Though we are on the right path to combat climate change, there's still a long way to go. We must cooperate government to government and create public-private partnerships. That is why I'm so pleased that the Danish Energy Agency have a close cooperation with South Korea and our close partner, Korea Energy Agency, and to see Danish companies ready to invest in South Korean offshore wind. Again, thank you very much for giving me the opportunity to speak at this P4G side event. I hope the next couple of hours will provide you all valuable insights. Thank you.
Thank you very much, Mr. Bøtzau, for giving a brief but very thorough overview of where we came from and where we are heading in the Danish wind sector with the most recent addition, the so-called Energy Island, 10 gigawatt Energy Island. Now, that was the end of the opening remarks. We will move into the presentations of this event, and we will begin with a presentation on the newly launched Cost of Energy study, which is a new study identifying key challenges and solutions in order to reach the ambitious Korean target of 12 gigawatt offshore wind capacity by 2030. It gives me great pleasure now to pass the floor to Mr. Jacob Rasmussen of the Danish Embassy in Korea. Jacob, the floor is yours.
Thank you, Finn. I'm very much looking forward to present and explore this particular session of the side event, being price. For us here at the Embassy, the Cost of Energy study has been a learning journey where we have with interest seen the study develop while talking to the many energy specialists in Korea and other countries. It all began as an idea of how we could support the Korean government in their implementation of its offshore wind plans. With Korean policymakers in mind, the study has thus been designed to analyze the impact of involving the key foreign offshore wind experts and companies to the Korean offshore wind market. It has been a pleasure seeing this study come to life by the dedicated work of the consultants that we have worked with, Covi, Agia, and Pondera. And they are with us here today online and will present the key findings of the study in a moment. In addition, also a special thank you to Korea Energy Agency, which are also here with us today, Korea Energy Economics Institute, and Green Energy Strategy Institute for providing their remarks on the study. Also, I would like to thank the Netherlands for taking this opportunity to join and support our study via an existing MOU that exists between our two countries on renewable energy. And lastly, thank you to the Danish Energy Agency in Denmark, Hans, Signe, and colleagues for their interest and financial funding of the study. Now, being in the middle of the P4G summit, focusing on creating strong green partnerships, it feels very fitting to introduce this timely and needed study of the cost of energy for future offshore wind farms in Korea, focusing on how we can join forces. I hope the study can contribute to bringing forward new ideas, partnerships, initiatives that will secure the effective implementation of the Korean offshore wind plans. And now I would like to leave the floor to Pondera, as we heard Pondera Consult, from Netherlands. It's a Dutch-based consulting house, and they will focus on the policy environment and supply chain. A warm welcome also to Rikke from Agia, a new Copenhagen specialist market insight company founded by industry experts. And lastly, but not least, Covi, a Danish international consulting engineering company that was founded in 1930. They will present on the employment effects and outlook of the study. So thank you very much.
Thank you very much. I feel honored to have the opportunity to present some of the findings of our research. And before taking a closer look to the supply chain and the cost of energy, I would like to take a short look at the policy plans of the Korean government. So therefore, this slide gives a short overview, and there will be a more in-depth discussion about policy, so I will keep it short. But if you look at it, you see the RE 3020, the Energy Master Plan, the basic plans for long-term electricity supply and demand, and of course the Green New Deal, all of importance for offshore wind energy. And also giving a program of measures and ideas and investments to make this all possible and happen. And if you look at the target that has been set, coming from 124 or 45, it's just how you look upon it, but a small number of megawatts already realized, and you have this ambitious target of 12 gigawatts in 2030, you know that a lot has to be done in the coming years. Next slide, please. If you take a bit closer look to the European and Korean development policies regarding offshore wind, you see that in the early years in Europe, there was a so-called open door principle applied. In this principle, individual project developers had to look for a certain area and start the developing process by their own. In the end, it led to a stagnation of the development due to a lack of regulation and site selection and effective permitting. So the current situation, and it took quite a while to get there, is a one-stop shop organization. And in that, it really reduced the administrative procedures, and also the site selection and the pre-site investigations, permitting, and also the grid connection has been taken care of for a large part by the government, and it was coordinated centrally. At the moment in Korea, you could say that this open door principle is also applicable right now. And this leads to an average quite small wind farm size, and also a large part of the risk that are allocated to the developers. The small figure, the small graph in the right below corner of this slide, you can see that the development of offshore wind in Europe has an exponential growth, and this growth will continue the coming 10 years. And I think growth like this is needed in Korea right now to achieve this 12 gigawatt goal for 2030. And the exponential growth is made possible due to the change in policy in Europe, and of course also by getting more and more mature supply chain for offshore wind. Next slide, please. If we take a closer look at the risks that offshore wind developers in Korea are faced upon right now, then you see that the costs in the early stage, even before they can apply for a permit, are relatively high. And the permitting process itself is scattered and complex and involves several ministries and governments, which causes delays at the moment. It turns out that for the developers, it is quite difficult to get a community acceptance for the wind farms. And also grid connection is at the moment not an uncertainty. What also is occurring right now is that when developers would like to deploy foreign wind turbines, that they come across some local contact expectations that are not very clearly stated at the moment. And last but not least, direct prices are declining, and that is threatening for the economic feasibility of the wind farms. So there are quite some risks at the moment, serious risks at the side of the offshore wind developers in Korea. Next, please. Coming from these risks and looking from a distance to this market, you can say that there are some key changes needed to create a more favorable policy environment for offshore wind. And we picked out 4 major ones. Firstly, we think it is very important to create a stable and long-term vision and roadmap by creating and converting new laws and regulations that really establish this favorable environment. A one-stop shop permitting process is really needed to increase the speed. It has been said today already often. And also we think it would be good to reduce the risk at the side of the developers and allocate some of these risks at government side where they can be managed much better. And as I said in the slide before this, also a very stable expectation on the side of the incentives. The financial incentives developers can expect is also of importance in the long term. Many of these elements are already present in the policy plans in Korea. So it is now a matter of implementing them fast to be able to get to the ambitious goals for 2030. Next, please. I would like to take a look at the supply chain right now and also especially see what partnerships could mean in the supply chain. Partnerships between European companies and companies from Korea. If you look at the wind farm, to start off with, you see some typical elements like wind turbines, of course, I would say, and the balance of plant. And the balance of plant is consisting of foundations, monopiles, jackets, floating foundations in the future, offshore high voltage stations, cables between the wind turbines and the offshore high voltage stations, and the export cable to the onshore substation, which gives the wind farm access to the national grid. The process of project development, of installation, and of course of operation and maintenance in the end are very important elements of the wind farm also. Next. As I said, we are looking at partnerships, and if we look at the project development process, first of all, we have to say it is a very multidisciplinary industry. It is a complex process, and it is a costly process in the sense that quite costly offshore surveys have to be done. But if you look at the high investments of the complete wind farm, it is a relatively small cost part of a wind farm, but with a very large impact on the success of the wind farm in the end. The typical strengths of European developers lies in their rich experience and their ability to detect risks in an early stage and being able to mitigate these risks. The Korean developers, on their side, have a deep understanding of the typical Korean circumstances and know what suppliers are available and can be used to, in the end, construct a wind farm. When it comes to a partnership, we see that a partnership between a Korean developer and a foreign developer could lead to a sharing of risks in this ownership and also lead to an optimal combination of local knowledge and global experience. So together, we think they can shape an effective supply chain and pick up the establishment of a wind farm effectively. Next. Wind turbines, a very important part, of course, I would say, of a wind farm. And what you see is a global trend of bigger is better when it comes to megawatts per wind turbine installed. But this trend is mainly based on the high wind speeds in the European circumstances of offshore wind. Offshore wind in Korea is asking for a larger rotor and a relatively smaller generator, so a specific wind turbine. The strength of European wind turbine manufacturers is, of course, their extensive global experience and track record at the moment. Korean manufacturers still have to enter the market with a larger wind turbine that is being developed right now. But they are already very well known for supplying important components for wind turbines and have a good track record in that. A partnership between European manufacturers and Korean suppliers could satisfy the local content expectations. And together, we think manufacturers could develop a specific wind turbine for the Korean and maybe also for the wider Asian Pacific region. Next. The balance of plant. Several parts, of course, in the balance of plant, like foundations. At the moment, you see that monopiles are mostly used and the most cost-effective, more cost-effective than jackets. But the soil conditions have to be suitable for monopiles, of course. In the future, floating wind turbine foundations will be of importance as well, especially in Korea, in deep waters. And we think that the Korean companies right now are very well able to supply the most elements of the BOP for a wind farm, except at the moment these very large monopiles that can be delivered from European companies. And together, we think in a partnership, Korean suppliers, European manufacturers can deliver all the necessary parts of the BOP. And in the future, it is very well possible to develop jointly a suitable and cost-effective floating foundation for wind turbines. Next, please. The installation of a wind farm is a very crucial phase, of course, I would say. What you need is specialized vessels, and in Europe, specialized vessels have been critical in reducing the installation times of a wind farm. Also, you need experienced crews, and if you look to the strengths of Korean companies, you see that they have a great track record in vessel design and construction. So the construction of specialized vessels in the future is very well possible in Korea and is happening actually right now. But it will take some years before these vessels become available. So in the meantime, I think it is a very good idea in a partnership between European contractors like Van Oort and Boskalis, etc., that can do the construction of wind farms together with Korean companies, and, for example, share crews and knowledge and insights and work together on the construction of a wind farm. Next. If I wrap up what I've just been saying about partnerships in the supply chain, I think that Korean companies can deliver a deep local understanding of the circumstances in Korea, a good insight in the available supply chain partners and the networks that are available for the construction of a wind farm, while the European companies can deliver their experience and expertise and technology from this already mature market in Europe. Together, they can complete all the elements that are needed for the supply chain to construct a wind farm. And we think in this cooperation, they can come to a faster and lower cost offshore wind farm build out in the future, and therefore bringing this ambitious goal closer. You can imagine that if it comes to solid partnerships, also the wider APEC market is possible to enter in a partnership between European and Korean companies. Well, thank you. This is my part of the presentation. I'd like to give the presentation to Rikke right now, and she will go more detailed in the levelized cost of energy. Thank you.
Thanks, Eric. I'm very pleased to be here today to present the results of the LCOE study. And this section will have a forward-looking view at the LCOE of offshore wind in Korea in a partnership scenario and in a domestic scenario. If we start, the study was structured. Next slide, please. The study was structured by defining reference sites in 4 of the 5 regional promotion areas pointed to by the Korean government. These are marked with green in the map. Incheon and South Jeolla in the west, they are suitable for bottom fixed deployment, whereas Jeju Islands and Ulsan are suitable for floating deployment, having water depth above 60 meters. Then the local site characteristics are defined, such as wind speed, water depth, distance to shore, and distance to transmission grid. Further, a commercial scale project capacity of 500 megawatt is assumed.
The permitting lead time of 5 years from today is assumed, giving a COD of 2026 for the first commercial scale projects. If we move on to the second slide, next step was to define the key technology assumptions for the two scenarios. And focus has been on turbines and foundations, as these are driving the majority of costs, and due to the fact that Korea has a very good starting point for supplying cables and steel structures. Starting with turbines, generator and rotor sizes have developed fast in the past and are expected to continue developing. Looking at what has been publicly announced by the suppliers, we see a rating of 14 to 15 megawatt with a 220 to 236 meter rotor diameter being offered from the European suppliers. Looking at Korean suppliers, they are currently pursuing the development of a tailored low wind turbine of 8 to 10 megawatt rating with a 205 to 209 meter rotor diameter. For market consultations, we have learned that global OEMs will likely offer their largest turbine platform for deployment in mid-2020s. In a downscaled generator version, which is optimal for low wind speeds, which are found in Korea. If we move on to the next slide, this translates into the following generic turbine assumptions applied in the study. Foreign manufacturers are expected to offer larger rotor diameters than Korean manufacturers. Further, it is assumed that foreign manufacturers will downscale their platform to correspond to a class 3 turbine, resulting in a generic foreign turbine assumption of 10 megawatt generator with a 230 meter rotor, and a generic domestic turbine assumption of 8 megawatt with a 207 meter rotor. Then if we go to the next step, due to lack of data on prices on domestic turbines, this study does not consider any price difference between the two. As European manufacturers have decades of experience developing new turbine platforms compared to domestic manufacturers, this study applies a number of modification parameters to the domestic turbine. The modification parameters applied are listed here, and these are based on a combination of expert experience and stakeholder engagement. Then we go on to the other key technology in a park, in an offshore wind park, the foundations. The following technology selections has been done for the reference sites. For water depths of up to 50 to 55 meters, monopile structures are assumed. These are relevant for Incheon and South Jeolla region. And for water depth of 60 meters and above, relevant for Jeju Islands and Ulsan, a generic semi-submersible floating substructure is assumed. Then the foundation modification parameters for domestic supply are defined on the next page. Similar to the manufacture of wind turbines, monopile fabrication have shown a steep learning curve in mature offshore wind markets. Thus, the parameters are applied to the domestic bottom fixed foundation supply. As the floating foundation concept is still under development towards commercialization, no adjustments are made at this point to the domestic scenario. Then we arrive at the results. Here we see that the lowest LCOE levels are found at the fixed bottom sites, ranging between 75 to 95 euros per megawatt hour in Incheon and South Jeolla. Although Jeju Islands and Ulsan's floating sites are closer to construction port and grid connection, it does not outweigh the higher costs associated with floating foundations. As a result, the floating sites have a bit higher LCOE, ranging between 98 to 120 euros per megawatt hours. For all sites, a partnership scenario provides the lowest LCOE values due to the use of a mature foreign turbine and monopile supply chain. On the next slide, if we compare the partnership scenario to the domestic scenario, we see a cost increase of 22% due to the smaller turbine assumed in the domestic scenario, impacting supply components across and capacity factor. And this is shown for the Indian bottom fixed reference size, whereas the cost add-on to the floating size is 19%. If we go on to the final slide, we look further into the future. A cost trajectory towards 2035 concludes that in a partnership scenario, LCOE for fixed bottom wind projects is estimated to fall from 80 euros per megawatt hours in 2023 to around 50 euros per megawatt hours in 2035, giving a reduction close to 40%. The trajectory assumes a number of key developments happening towards 2035. These relate to turbine size assumptions, both for the low wind regime turbine and also for the high wind regime turbine. It also assumes that continuous and successful commercial build-out will happen and the domestic supply chain will mature. Finally, it also assumes a declining supply costs and efficiency improvements, both in installation and technology. Summing up, the LCOE study finds that in a partnership scenario, it offers the opportunity to bring proven wind turbine technology and monopile foundation know-how to Korea, and thereby jumpstart offshore wind as early as mid-2020s. Korean manufacturers can establish a track record and increase their competitiveness. Partnership can help Korea build faster at a lower cost, which is demonstrated with this study. Thank you. And then I will hand over to Morten from COVI, looking into the employment effects.
Thank you, Rikke. It's my pleasure to be here today and present you with some results on the employment effects of installing offshore wind in Korea. If you can go to the next slide. We have been looking at a 500 megawatts site at the 4 sites that Rikke described, and also in the 2 scenarios, the partnership scenario and the domestic scenario. And what we see in the table are full-time employee years for each of the sites based on the 500 megawatt installation. And what we see is that in a purely domestic scenario, we expect that the employment effects, so local job creation in Korea, would be higher, of course, and also something on the order of 50% higher than in the partnership scenario. However, we expect that the capacity of the local supply chain will be a limiting factor for growth in installed capacity in the short run, which brings the partnership scenario very much into play. We expect that the partnership scenario would be able to enable a faster growth in installed capacity. So even though it creates fewer local jobs, the faster growth in installed capacity could offset that and actually create more jobs in the short run. We can also see that these offshore wind farms represent a substantial investment and also a substantial contribution to local job creation in whichever scenario we look at. And especially during the construction phase, where the offshore wind farm construction will employ thousands of laborers. The operation and maintenance phase is stretched out over the lifetime of the project. And so even though it still sums to many thousands of full-time employee years, it will represent fewer permanent jobs than in the construction phase. Next slide, please. So what drives this local value capture? First off, the political long-term commitment to a pipeline of offshore wind farms is important. It's important for establishing the local manufacturing and installation capacity and providing the stability needed to develop that. we also believe that a graduated uptake of capacity is important in the short term to mitigate the capacity constraints within the local supply chain, and in the midterm to support the development of the supply chain and building up the capacity and expanding the capacity within the local supply chain. Availability of adequate infrastructure is also important to retain the local jobs and create the value locally. This includes availability of ships and ports and installation and operation and maintenance facilities. Technology choice could also be a factor that impacts the local capture of jobs. As Rikke mentioned, floating foundations could actually play into Korea's strengths as a steel manufacturer, as opposed to fixed bottom foundations. And then finally, we believe that in the short term, the partnership approach could provide a faster pace of uptake of wind power, and simply having a faster pace of uptake would actually create more local jobs than a domestic approach with a slower uptake of wind power. So thank you. That was my words on this. Now I will hand it over to Lisa.
Thank you, Martin. Can you hear me? Is my audio on?
Perfect.
No? Okay, great. Thanks. Thank you very much, Martin. It's also my pleasure to be here today to give the outlook here at the end of our presentation. For the last 30 minutes or so, we have given you the most important results from our very wide-ranging study. And I would like to take this last slide as an opportunity to bring all these threads together and to talk about what does this mean for the future of offshore wind in Korea. If you look on the left side of the slide, you will see the key challenges across all the areas that we have discussed today listed. And it begins with a point that Eric had mentioned at the beginning in the policy section, which is that swift action is needed on the existing plans to address permitting, to reduce developer risk, and to increase the size of the wind farms. These plans exist, but we just wanted to emphasize that the action on them needs to be quite swift. The second challenge that we expect is the timely commercialization of at least an 8 megawatt domestic turbine. Historically, OEMs who are making this jump from a smaller platform, which is what the Korean manufacturers have now, to a much larger platform, have been subject to delays. And this could possibly impact the domestic manufacturers as well. The next 3 points are all about how the challenges that the supply chain will face, both in terms of capacity and in terms of capability. So in terms of capacity, the domestic turbine production will need to be increased by a factor of 10 in order to meet the goals. Similar ramp-ups will be needed in weaker parts of the supply chain or parts that have yet to be developed, such as extra large monopiles. And the installation rate also must be increased by even more, by about a factor of 20. For all of these things, of course, Korea will need to hire and qualify a lot of laborers for this new industry, which is of course fantastic, but it takes some time. If we take all of these challenges together, they present a clear picture. And that picture is that if these challenges are not addressed, there's a high risk of missing the 12 gigawatt goal. In addition to that, the wind farms that are built will be built more slowly and at a 19 to 22% higher cost. In our study, we looked at ways to address these challenges. And what we found is that the partnership scenario and solutions are a very natural and effective way to do that. It starts with bringing, as you can see on the right side of the slide here, it starts with the foreign manufacturers who are able to bring proven turbine technology from global leaders, but at the same time, they can leave room for the domestic manufacturers to install wind farms and gain the track record that is so critical to their competitiveness. The partnership solution also brings together experienced European developers and Korean developers with deep local knowledge to de-risk the projects. And in the next points, as you see, it can help with the supply chain. It can even out, it can strengthen the weak spots, even out the gaps, and encourage a sustainable growth that Morten has indicated is so important to capture this economic value long term. And of course, the partnerships can also provide training and knowledge transfer opportunities on state-of-the-art wind farms that exist in Europe, and train the local workers in an industry that will hopefully support them for years to come. If we take all these things together, you can see that the partnership solutions scenario enables a faster build out of energy at lower cost, and equally important, it puts the Korean partners on the fast track to competing at a global level. We thank you for your time today. We hope the presentation was interesting for you. We could only give you, of course, a brief overview of the very broad study. But if you're curious, anyone can download the full report here at covi.com/insights. Thank you, Jacob. And Finn.
Thank you very much to all the previous speakers for a very interesting presentation of this new report. We know there are several questions from the audience, but unfortunately, we don't have time right now to answer them, but we will try and follow up later in the program today. So thank you very much to Jacob for introducing, and to Lisa Keaton and Morten Hermann from COVI, to Rikke Winther Nørgaard from Aegir Insights, and last but not least, Erik Ernst from Pondera. We will now move on to the next part of the program, where we are very fortunate to have Mr. Stig Uffe Petersen, who is the Deputy Director General of the Danish Energy Agency. Stig will present our experiences from Denmark on the legislative framework around implementing offshore wind. Stig, the floor is yours.
Thank you very much, Finn. Executives, Chairman, ladies and gentlemen, good afternoon in Seoul, Korea, and good morning here in Denmark and in the Netherlands. It's an absolute pleasure to take part in this P4G offshore wind event. The focus of my presentation this morning or afternoon will be one-stop shop, maritime spatial planning, and the energy islands with perspectives and experiences from Denmark. Initially, let me turn to Denmark's pathway towards climate neutrality in 2050, where offshore wind will play a crucial role in the energy mix. When it comes to ambitions and achievements within the green transition, we have high ambitions and strong political commitment. In 2019, we had an average of 47% wind power in the power mix, and we hold a top rank in security of power supply with only 20 minutes of lost load per year as an average. And at the same time, Denmark enjoys one of the EU's lowest wholesale prices. One of the first stepping stones to achieve climate neutrality in 2050 is the Danish climate target of 70% reduction in greenhouse gas emissions by 2030 compared to 1990. While maintaining a high level of security of power supply, 100% of our electricity will be from renewable energy in 2030, especially driven by expanding our offshore wind. Offshore wind in Denmark has more than 30 years of experience. We started out with a 5 megawatt wind farm. By the end of this year, 2.3 gigawatts will be feeding into the grid. 2 new large-scale wind farms, offshore wind farms, are currently being tendered. They will add an additional capacity of up to 2 gigawatts by 2027. At the same time, Denmark is taking offshore wind development to the next level with our plan for 2 energy islands connected to an additional 5 gigawatt offshore wind. With this addition, Denmark will have approximately 9 gigawatts in operation soon after 2030. Now let me turn to today's topic and dive into the Danish policy experiences regarding offshore wind and one-stop shops. What is the Danish one-stop shop and why a one-stop shop? In Denmark, the Danish Energy Agency serves as a one-stop shop. This means that the Danish Energy Agency serves as a single point of contact for the owner of a wind project, and we issue all the necessary permits and licensing based on coordination with relevant authorities. This mandate is given to the Danish Energy Agency by law. The one-stop shop ensures a clear, transparent, and smooth consenting process, and it most of all reduces the risks and uncertainties, and thereby developers are able to produce electricity much cheaper. It gives them confidence. And the lower prices are achieved through lower bidding prices, and that's crucial. That's really a crucial point. Furthermore, the concept ensures a better coordination and understanding of the projects at the offices of other central and local and regional authorities. In relation to the one-stop shop, I would also like to acknowledge Korea's progress on this matter. Launching of the one-stop shop bill, which is currently going through the parliamentary process. As part of the one-stop shop concept, the Danish Energy Agency is responsible for running a tender for a designated area and hereby branding the project in an open competition to ensure that the best project is selected at the lowest price. The object is to ensure that the licenses are given to the most cost-effective projects in a fully transparent process and that all bidders are on an equal footing. Allocation of designated areas for offshore wind power is based on several parameters, including economic, technical, grid, and environmental consideration. And a starting point for the site selection is the maritime spatial planning, to which I'm turning now. Maritime spatial planning is an area that needs special attention, at least in our experience, and it requires cooperation across various governments institutions. Even though the ocean seems an open and a legitimate space, there are quite a lot of different interests at stake here, and they must be considered before engaging in planning of offshore wind. A maritime spatial plan forms the basis of the coordination of the many uses of the sea. The key benefits and reasoning for maritime spatial planning include supporting political target setting and long-term planning, ensuring that human activities at the sea take place in an efficient, safe, and sustainable way, reducing conflicts between sectors and creating synergies between different activities. Protecting the environment is also an issue through early identification of impacts. And finally, encouraging investments by creating transparency, predictability, and clearer rules. The first step in the maritime spatial planning, that is the rough screening. It identifies areas with good conditions, for instance, wind resources and water depth. At the same time, the rough screening identifies the different types of interests at stake. After having identified potential areas for offshore wind, the second step is the fine screening. It's a deep dive into local site conditions where we focus on, for instance, seabed conditions, environmental conditions, grid connection opportunities, and the costs, both CAPEX and OPEX. By performing an economic ranking based on levelized cost of energy, the fine screening ensures that the most attractive sites are developed first. These sites will be possible sites for future tenders. Let me turn to the latest maritime spatial planning we did. It's based on our energy agreement from 2018. The request, according to our politicians, was to identify more than 12 gigawatts suitable area for offshore wind, and the request was met. This latest maritime spatial planning was an important step in identifying the offshore wind areas for future tenders and also in relation to our energy islands. And let me give you a little background on the concept of the energy islands, which is the next step in development of offshore wind in Denmark. The two energy islands that we are aiming to construct were part of our latest climate plan that was agreed by our politicians in June last year. The Danish Climate Action Plan holds the objective to establish two energy islands. The island in the North Sea, west of Denmark, will first need to be constructed to serve as a hub for offshore wind farms in terms of capacity. This island should accommodate 3 gigawatts initially, with the potential to connect more than 10 gigawatt later on. The second energy island is the energy island of Bornholm in the Baltic Sea, which will be a physical hub and not a constructed island for offshore wind farms with a total capacity of 2 gigawatts. The background and reasoning for the energy islands are several. Obviously, the energy islands will support the offshore wind build-outs. The energy island also changes the perspective. We're going from connection, radial connection to individual countries to creating hubs that are connecting wind farms to several countries. The energy islands also support balancing the excess renewable energy produced in one country with storage in another, and they aim to increase the security of supply. In fact, the energy islands will be green power plants at sea. These energy islands will serve as power plants, gathering and collecting green electricity from surrounding offshore wind farms. The energy island will ensure distribution of power between countries connected via the electricity grid, both to Denmark and neighboring countries. The Danish Ministry for Climate, Energy and Utilities have entered or hope to enter into agreements for closer cooperation on interconnectors from the energy islands with various countries. The energy island in the North Sea will be an artificial island, and the island covers an area of at least 120,000 square meters. That's equivalent of 18 soccer fields. It will be the largest construction project in the history of Denmark, with a total estimated cost around 210 billion Danish kroners, equivalent to 49,000 billion won, or 34 billion US dollars. Fully implemented, the island will provide 10 million European households with green electricity. The island in the North Sea will be considered critical infrastructure, and it has been decided that the Danish government and state will have a majority ownership. Through the state, the state will own the majority of the project, and the intent is to enable fertilization of private companies with regard to project development, technology, and finance. Private companies will be crucial for the project. They will bring innovation, flexibility, and cost effectiveness to the project. The Danish Energy Agency plans to start the tendering process of the island itself in 2022, with the announcement of the winner in the beginning of 2023. The energy islands also holds a long-term vision and possibility for power to X, power to other fuels. Offshore wind energy is at the core of how Europe can go carbon neutral, playing a crucial role for the EU to reach climate neutrality by 2050. The energy islands are preparing us to enter a new area of green energy production, a paradigm shift, so to speak, in the way we approach offshore wind power. The intention is to connect energy hubs with interconnectors to bordering countries and support sector coupling through power to hydrogen conversion. PTX, or power to X, is expected to play a crucial role using wind power from the energy islands. The conversion of power to another energy carrier allows the broader energy system, such as transport, shipping, and aviation, to go green. With the political agreement and climate action plan, Denmark takes the lead in the green transition and a new step paving the way for green recovery with some of the largest infrastructure projects ever. On a final note, I would like to highlight the excellent cooperation we have with Korea Energy Agency. We look forward to continue our fruitful partnership, and I think together we can pave the way for the Paris Agreement goals. Thank you very much.
Thank you very much, Stig Petersen, for giving this impressive presentation. Being a Dane, you can't help but feeling a bit proud when you hear about the scale and the vision for the energy islands. So again, thank you very much. Now, let's turn to the next speaker of today. It gives me great pleasure to introduce Min-Soo Kim, who is the leader of Wind Power Project Division at the Korea Energy Agency. Mr. Min-Soo Kim will present on how to create an integrated farm of offshore wind in Korea. Mr. Kim, please, the floor is yours.
Hello, everyone. As introduced, my name is Kim Min-soo, representing KEA. Once again, hello everyone. Let me introduce myself once again. My name is Kim Min-soo. I represent Korea Energy Agency, or KEA. So today I would like to share with you the policies backing the integrated farm in Korea in relation to the offshore wind farms in Korea. So now talking about the integrated farm, let me tell you about the background. And in the past decade, Korea went through various difficulties and hurdles, and I would like to share that as well with you. Next, I would like to talk about the procedures and the main gist of the integrated farms. The Korean government in 2010 announced the Southwest Sea roadmap. I believe that is actually the beginning of the offshore wind in Korea. So that was back in 2010, and after the roadmap was established and announced in 2011, there was a more detailed plan that was introduced. If you look at that particular plan, in the West Coast, there were to be 2.5 gigawatts of a farm in 3 different stages or phases. This farm in the West Coast were to be again divided into 3 different phases. The first was the demonstration phase, the second is the pilot phase, and the third is the actual large commercialization stage. And in 2011, when the plan was established and announced, it wasn't simply about wider adoption of the offshore wind. It also included how to foster and promote the industries and how to also garner the residents' acceptance. It was more of a comprehensive plan that was laid out in 2011. And at that time, it was a government-led announcement, but at the same time, several developers or private sectors were keenly interested in the offshore wind adoption or build out in this country. So I would like to bring your attention to the fact that there are 3 phases, And the first phase was to develop 100 megawatts by 2013. And the phase 2 was 900 megawatts by 2016. And phase 3 was almost 2 gigawatt by 2019. That was an initial plan. But usually we say 8 years, usually on average, for a farm to be developed. But when that initial plan was announced, the ambition was to get all of that in just 3 years, which is quite ambitious. And as a result, they wanted to speed up the process. But if you look at what happened in reality, the phase 1 were only achieved in 2020. So that's about a 6 or 7 years of a delay just for the phase 1. And capacity-wise, also the initial goal was also quite reduced. And if you look at the second and the third phase, it's on track right now. For phase 2, the initial plan was to go separately from phase 2 and 3 one by one, but right now we're actually doing this all together simultaneously. But phase 2 obviously is going at a higher speed because there's already the EBS, the EBL, the license being already permitted. And right now we're doing again phase 2 and 3 all at the same time. So past decade, we saw a great ambition by the government. So it was a government-led initiatives and the plans. But despite this, we were met with very much of hurdles. And let me tell you what those difficulties were one by one. First was on the site development. Both private and public sectors faced a lot of difficulties because of the lack of acceptance or lack of communication with the fishery communities, also residents. And because of that, only after a site was developed or already decided, the communications took place with the fishers and with the residents, which caused a quite a substantial delay to the process of the development. Also for the residents' acceptance, and each individual developer were to communicate with the residents, but there was a big gap of understanding and there was no institutional support, any schemes to support for the developers to garner the residents' acceptance. Same thing in the permission as well. Any permit process that you should go through in Korea is extremely complex. It's not just about getting a license or permit. You have to look at each different acts that govern each different areas, making it extremely complex for developers. And even the local governments, they are actually in charge of the offshore wind, but they don't have any incentives to really get involved in those projects. So they kind of took a backseat in these initiatives. And all of that together caused substantial delays in the offshore wind adoption. And that's why the government's ambitions plan that was initially announced in 2010 did not actually come to fruits. And therefore, the competitiveness of the industry in Korea has rather been compromised. Let me also tell you about the Ministry of Fisheries and their MSP, or the Maritime Special Planning. So there are many activities that take place on ocean, and the ministry has divided them into 9. And there are areas that different activities can take place at the same time in redundancy. And the MSP is established just to make sure that they are coordinated. And for offshore wind, it's actually, if it falls on number 3, the energy development zone. But again, some activities can take place in redundantly. But as for the energy development, there are conflicts of interest, especially with the fishing community, making it very difficult to elicit the acceptance of the residents, especially the fishermen. And in areas that already had some of the offshore wind projects, they were able to receive their spot in the energy development zone. But for new or planned projects, it's extremely difficult to find their spot there. In 2019 and since then, we've been working closely with DEA. And DA already covered that in Denmark, there is a one-stop shop, and they have accumulated a great level and wealth of experiences, and that has been extremely insightful to us. So in Denmark, let me briefly mention what it is and what we took inspirations from. When there is any project regarding offshore wind, there should be a policy decision, and then there should be a communication between different ministries regarding the permitting, and there should be a very clear set of rules and procedures, and that's what was happening in Denmark. But obviously, until last year in Korea, the situations were quite different. The procedures were not clear, and it was not well established. So these were some of the difficulties that we went through over the past decade, but we have gained much knowledge from DEA. So last year, based on all of that, we came out with the plans for offshore wind power development. And the initial gist of that is to construct 12 gigawatts until 2030. But what's even more important than that is that it's not simply a build out of new construction, a build out of the offshore wind, but it's more focused on a win-win situation with the residents and with the fisheries. So that was an overriding goal that we wanted to do with the 12 gigawatts. So for that, we had 3 specific plans. Let's go one by one. The first is about site selection. Instead of leaving it to the developers, we thought that it was important to have the government at the forefront, and also a permitting process had to be simplified. The second plan was about the residents' acceptance and environmental values that needed to be honored. And the third one was also on the industry factor, that their competitiveness needs to be developed. So these are the 3 specific plans, and all of that can be really summed up into what our concept of integrated farm. Again, for the integrated farm, the leader is the government in this case, and the local governments in this case finds or identifies the areas for the integrated farm. So let me tell you the procedures regarding the integrated farms. Basically, the owner of this kind of concept is the local government or municipalities. So what they do is they find a large-scale project in a very systematic way. So the local governments will have to work with the residents and listen to their voices, and they will have to first come up with a development plan based on the opinions of the residents. And then they will apply to the Ministry of Trade and Industry and Energy for the designation of an integrated farm. And when the designation is granted, then the local government, together with the developers, will actually embark on the construction of such farms. When the farm is to be constructed, then the local government again will have to partner with the developers through bidding or tender processes. So the developers were actually going to be the hands and the feet for the actual construction and the development. So for this planning stage, what's needed foremost is the site selection. And for that, the government has set what's called the site information map or the consideration zones. Again, these 2 fall on the responsibility of the governments. The map isn't simply about the wind resources, it goes beyond that. It contains permitting information and subsea situation, and also it details what kind of fishing activities and how much of such fishing activities are taking place in a certain area of a concern. So by the end of this year, we will have accomplished the site information map. And with that, Ministry of Trade or Ministry of Fishery, Ministry of Environment will be able to see and share with the people on areas with the highest wind conditions and the least environmental impact. In that case, consideration zones would have been already designated by the Ministry of Trade. So based on that, the feasibility test can take place by the local government. So now, and even at this stage, the central government is considering to give a financial support for the feasibility surveys as well. So there is a deliberation process or assessment process, and the criteria are about 5 of them. Technically, there is a permitting or grid connection that is to be assessed by the Ministry of Trade. And it also looks at the residents' acceptance and environmental impact, and also plans for continuing to get the residents' acceptance and going forward. Also, Ministry of Trade looks at whether the project has any plans for profit sharing with the residents. So all of these criteria are assessed and deliberated, and when Ministry of Trade believes that it's a right fit, then the consideration zone title is granted to that particular local government and the farm. And there has also to be a deliberation process amongst many ministries before the consideration zone is granted. Also, local governments will have to go through to agree upon what procedures and processes to go through for that designation. One of the biggest challenges that we faced over the past decade was a residence acceptance. And for integrated farm, that also becomes an extremely crucial topic. And for that, we made it obligatory to have a residence acceptance before an application is made. So the actual stakeholders will have to be involved early on for the site investigation and decision. For example, it could be discussions on site candidates, whether they are suitable for an integrated farm. And it also has to include profit sharing schemes. Also, the environmental monitoring measures will have to be included at this public-private joint conferences. So through these kind of public-private councils or consultations, we may come to an agreement. Only then we can implement this integrated farm. If not, the stakeholders will have to go through all these requirements and the complaints by the people and then resolve them before they actually apply for the integrated farm. Again, the local governments have to go through rounds of town halls meetings, and this becomes a requirement under our new plan. So basically, these are communicating with the local residents and the private sectors as well. And at the final stage, before the submission of the application, all of that elements will have to be included in it. Now, local governments, when they went forward with an offshore wind, did not see any incentives. Therefore, they were not motivated to participate or get engaged with the private developers. Now, the situation has changed because we have now a maximum 0.1 REC weight given to a local government-led projects. Now, that could be returned to people. Now, that can be a profit to the local government, which is a great incentive. Now, also for maritime spatial planning, due to the conflicts of the interest, some complaints or the civil complaints are lodged many times. So in the areas where integrated farm is granted, we are allowing that particular area to be reflected as an energy development zone in the MSP, not to cause further conflicts. And for the integrated farms, also a more streamlined permitting process will be applied under our plan. So I have shared with you more details of the integrated farm schemes, and for that to have more clarity, government has created a guidelines. The guideline is first on the public-private joint conference guide, and another one is on the resident acceptance, and the last one is on the profit sharing. And I believe we will put them together by the end of this year to be disclosed to the public. And also, offshore wind is something of a long duration, and the biggest problem usually is grid connection. So of course, developing construction takes a long time, but the grid connection, a completely new one, takes a whole lot of time. So the government but wishes to reduce the time. And for that, government is looking to find a public grid connection network early on. Well, of course, the development plan will have to be made for the grid connection. But even before the electricity business license or EBL is granted, the government is trying to use, even before the EBL is granted, government is trying to secure public connection network beforehand to make sure that by the time the construction is completed, the grid connection can take place right away. And you know all about the REC scheme. Now, REC is finalized during the construction period, which is about the end of the 8-year schedule. In that case, there is high level of uncertainties, high level of risks, and also it's really difficult to make the final investment decision or the FID. Therefore, what we're looking at right now is to give an early notice of the REC rate to the developers in question so that they know where they're heading to. So these are some of the incentives that we are trying to introduce. And I think with that, we can, or we expect to reach that 12 gigawatts goal. Well, offshore wind goes one by one. And we have the 12 gigawatt plan, but going even further, our ultimate goal is all the way to the 20 gigawatts. And right now, I think with what we have, we can be on time, on schedule. Thank you very much. That's all that I have. Thank you all.
Thank you very much, Mr. Min-Soo Kim, for laying out the history behind where you are today and your extremely ambitious goals with the new plan for the offshore parks. I have a question. If you could please stay on the stage. You touched upon the previously announced roadmaps aiming at several gigawatts by 2019, and you also mentioned that there were major challenges underway to reach that target. You have addressed them in the new 2030 target. There's one aspect in particular I would like you to elaborate on, and that's the question of resident acceptance, public acceptance of wind farms. I know it's, as you said, it's obligatory now to hold public-private joint conferences, but perhaps you could tell me a little bit more, how well are you progressing on this involvement of residents? Thank you.
Thank you for the question. Well, let me give you some of the examples that are taking place on the field. So right now, there is the government-led projects in the Southwest Sea. The first phase was constructed in 2020, which is a very much of a delay because of an opposition from the residents. So from 2019, North Province and many local governments have got together in this public-private partnership or the conference, and they came to an agreement after a round of deliberations. So it's been about a year since such an agreement was gathered, and that agreement is about second phase and the third phase site selection. So we've progressed that much. So right now, residents, especially the fishing communities, opinions are very well reflected in their development plan, especially for phase 2 and 3. That's all. Thank you.
Thank you very much, Mr. Min-Soo Kim. Now let's move on to the last presentation for today. We will hear from Mr. Kyung-Hwan Kim, who is Principal Researcher at Korea Research Institute of Ships and Ocean Engineering. Mr. Kyung-Hwan Kim will give us the current status of research and development on floating offshore wind in Korea. Please, Mr. Kyung-Hwan Kim, the floor is yours.
Thank you for the introduction. So as introduced, my name is Kyung-Hwan Kim from the Korea Research Institute of Ships and Ocean Engineering, or KRISO, and we do R&D on ships and ocean engineering, and we are an entity under the government. And today I would like to talk about the current status of Korea's technology-related R&D on floating offshore wind turbine. How do I turn to the next slide? So first of all, I would like to talk about the global status on floating offshore wind turbines and R&D projects that are currently being conducted in Korea regarding FOWT and future technologies, and overall summarize my presentation. So this is something that you all know already. So the wind turbine capacity is increasing dramatically these days. If you look at the products of major companies, there's Vestas, Siemens Gamesa, and GE, and they are currently producing turbines up to 14 or 15 megawatt. So the graph that you're seeing right now is a history of the growth of wind turbine capacity. As you can see, in just 2010, the turbines were 8 megawatt or 9 megawatt or so. And from 7 to 8 megawatt, 10 years from now on, it has grown to 15 megawatt turbines. So a lot of people say then that the turbines will not grow further than 15 megawatts, but we are actually seeing bigger turbines being developed. And I do believe that perhaps within 2030, we will be able to see 20 megawatt turbines. Direct drive types have been developed up to 15 megawatt. And as far as floating turbines are concerned, they are in the color of yellow in this graph. At first, it started off at a 2 megawatt class, but recently you can see that it has reached up to 9 megawatt class. They are actually being applied to pre-commercial sites. So together with the growth of the wind turbine capacity, I believe that perhaps floating offshore wind turbines can grow up to 15 megawatt or even 20 megawatt 10 years from now on. So as you know already about floating offshore wind, so we have seen these onshore wind turbines moving to offshore wind, and therefore it gave way to the development of monopile jacket and tripod structures. And when we ventured out into the deeper waters, we developed the floating structures like the semi-submersible, TLP, and spar, and so on. And the cost of these structures, you probably know them well already. I'm sorry, so not the price. Oh yes, the price of these turbines for these structures or foundations that are installed in water depth that is rather shallow are less costly than the ones that are installed in the deep waters. And of course, a lot of R&D efforts are underway to reduce this cost and also to create a floating offshore wind turbine. And there are three types: semi-submersible, spar, and TLP. And as you know, as for semi-submersible, it has a low transportation and installation cost, and it can be installed in relatively low water depth. As for spar is concerned, it has a very simple structure, and its steel weight is relatively light. However, the con is that it requires a special installation vessel, and its installation cost is rather high. As far as TLP is concerned, it's a tension leg platform. So it has high stability, and therefore the turbine can be very stable, but it has a high mooring installation cost. That's the downside. So today, semi-submersible and spar types have been developed to a great extent. And if you look at the expectations or outcast or forecast of FOWT, according to Carbon Trust, the cumulative installation capacity up to year 2020 is 124 megawatt. However, if we look at the forecast, in 2030 or by 2030, we will be able to reach 10 gigawatt and 2040, 70 gigawatt. So we will be able to see a significant growth than what it is today. And Carbon Trust especially says that Asian countries, especially Eastern Asian countries like Korea and Japan, will be able to see a great growth in the installation of FOWT. And the reason is because in case of Korea, we have limited sites onshore. And of course, there is a low public acceptance when it comes to onshore wind farms. So therefore, that's why the Carbon Trust has made such a prediction. And if you look at the technology readiness level, Principal Power has wind float, and it is actually developing at a faster rate than its competitors. So it has gone through a demo, and Windflow Atlantic was installed, and through the Kincardini project, it is at level 9, and other semi-submersible structures, let's take a look at them. So Japan has pursued with Fukushima forward phase. It is at the level 7 right now, but not up to level quite yet. And there's Equinor's high wind as well. This uses a spark type structure. It went through demonstration and it created the High Wind Scotland, and High Wind Tampen project is now on its way. It has reached its pre-commercial level, as you can see from this graph. So let's take a look at how high wind float. So it uses spar structure. And I do believe that the concept design was suggested in 2011, and the 2.3 megawatt class demonstration was carried out in 2009. And for the first time in the world, a first pre-commercial floating offshore wind farm was established under the name High Wind Scotland. And it uses 6 megawatt FOWT to a total of 30 megawatt. And it has been in operation since October 2017. And as far as High Wind Tampen project is concerned, it required 11 units of 8 megawatt FOWT, and the substructure is now being installed. It's been developed and it's being installed at the site right now. And Windfloat uses semi-submersible structure. It's a 2 megawatt class, and demonstration was carried out. And installation was made in 2011. And for the next 6 years, it produced electricity of 16 gigawatt. And now a project called Windflow Atlantic Projects is being carried out. It involved 3 units of 8.5 megawatt FOWT, and it's currently in operation in the Portuguese Sea. And there is the Kincardini project, or KOWL project. It involved 5 units of 9.5 megawatt FOWT. As you can see from the picture below, the last substructure is being carried out to the Aberdeen Bay. So the complex or the farm is actually being constructed at this moment. So those were the projects that were ongoing. And let's see what R&D projects took place regarding FOWT. To focus on the systems, there was a deep wind project in Europe. As you can see, it involved the design of a 20 megawatt class vertical axis FOWT. So there were fatigue analysis and dynamic analysis and power generation analysis were conducted, and there were control and safety maintenance, and a reduced scale model test was carried out as well. And there was also another project called InWind project. It involved designing a 10 to 20 megawatt FOWT system. There was a conceptual design, and a lightweight rotor was developed. And electric and mechanical conversion took place, and as well as floating structure. So the 3-column floating structure was actually introduced during this project. So the most recent projects are Life S50 Plus project. So it has been conducted in Europe, and it involved the development of 10 megawatt class next generation FOWT platform. So the design concept was introduced, and the concepts with most potentials were selected on 4 types of platforms, and a concept evaluation was carried out. And there was also a model verification test. So while carrying out these projects, numerical model verification took place, as well as uncertainty and risk management. And a design guideline was developed as well. And Marine and others have pursued JIPs, or joint industry projects, to see or to determine the operating standards of various maintenance vessels in preparation for offshore wind turbine. And it developed a maintenance cost prediction model and so on. And there was also a project on the development of a 10 megawatt and FOWT system, mooring and anchoring system. And there's also Lions Hat JIP. So there was a verification of a verification carried out for large scale FOSW. So here in Korea, as you know already, the government announced the Green New Deal. And the core of the Green New Deal is energy conversion by solar, wind, and hydrogen. And President Moon Jae-in has announced that the enlarging or ramping up or building up our offshore wind turbine 100-fold is the first step in the Green New Deal. Therefore, we believe that there will be a lot of efforts in developing the offshore wind turbine going forward. So an LCOE analysis on FOWT in Korea was conducted, and as you can see, there is a high potential for wind energy offshore than onshore. And except for the East Sea, which is rather deep, most of the water depth in the nearby Korea are less than 150 meters. So therefore, it is advantageous for FOSW installation. And the further we go out to the And of course, in those areas, we have stronger wind power, which means that it's more advantageous for FOSW. But what's really difficult here in Korea is gaining public acceptance. So for most projects, gaining public acceptance has been a challenge. And a lot of projects were delayed. So rather than focusing on the technology in the future, perhaps our focus should be on resolving this public acceptance issue. So Doosan, Unison, Hyosun, and Hanjin are manufacturers of turbines here in Korea, or FOWT here in Korea. And Doosan and Unison are continuing the development of offshore wind. So it has 3 megawatt and 5 megawatt turbines. And they are currently trying to make this go up to 10 megawatt. As far as Unison is concerned, it has a product of 4.2 megawatt, and it is trying to create turbines that could go up to 10 megawatts. That has been publicly announced. So let's take a look at the technology gap between Korean companies and foreign companies. So as you can see, I've divided the turbines into their capacities from 1 to 5 megawatt, 6 to 10 megawatt, 11 to 15 megawatt, and 15 to 20 megawatt. So the offshore wind turbines, So all the companies have this 1 to 5 megawatt products. As far as 6 to 10 megawatt is concerned, Doosan and Unison are currently developing them here in Korea. Vestas, GE and Siemens Gamesa already have 6 to 10 megawatt turbines, and they are now in the process of developing 11 to 15 megawatt turbines. When we compare in terms of FOSW, as you can see from this table, Hywind, Windflow, Fukushima Forward, through these projects, 4 companies have completed their demonstration, and based on that, they are able to utilize 6 megawatt turbines to carry out Hywind Scotland, Windflow Atlantic, Windflow Kincardine, and Hywind Tampen projects. And their technology is advanced to the level where they can conduct pre-commercial for FOSW. And in terms of R&D, in wind and lifetime S50 are now pursuing the development of a bigger wind turbines. But unfortunately, here in Korea, R&D for platform engineering took place centering on Doosan Consortium, and that actually involved 5 megawatt turbine. And after that research, I'm sorry, that was Ulsan Consortium. And now today there is Doosan Consortium, which is trying to carry out demonstration using a 6 megawatt turbine. So there's a lot of technology gap between foreign and Korean companies when it comes to FOSW. So let's take a look at some major R&D projects that were pursued in Korea. Regarding FOWT, most of the R&D efforts were led by government. It injected government investment. So from 2016 to 2019, there was a kilowatt class demonstration for the development of floating offshore wind turbine. Mastek Heavy Industries and Unison took part in this project, but the project was not met with a success. And from 2018 to 2020, there was a FOWT design project. And afterwards, recently, starting from 2020, there is a transportation and installation project that is ongoing. So it revolves the development of a 70 kilo voltage cable, and there is also a project that involves digital twin technology. So to just briefly go over the detail, so megawatt class FOWT design task was carried out from 2018 to 2020. If you look at the pictures on the left, we developed turbine systems and platform. It was a spar platform, by the way. And we conducted related model tests to see their performance. And afterwards, there is a megawatt class FOWT demonstration being carried out today. So here, it involved 8 megawatt class large floating offshore wind power system development and demonstration. And Doosan Heavy Industries is leading this project. And there is a test site in Jeju Island where we can carry out a test of this project. And we have related undersea cables and offshore substations as well. So testing will probably be carried out on this site in Jeju Island. And there is the digital twin FOWT project being carried out in Ulsan. You can see the related pictures on the left. And there is also the transportation and installation project. We do not have a lot of related experience on this. So CGO is leading this project to conduct development in relation to TNI. And there's another project led by LSCNS to develop 70 kilovoltage class dynamic cable. So you can see the picture of the cable being tested on the right. So as you can see, when it comes to FOSW, there is a lot of gap between European companies and Korean companies. Even in TRL, we are now only at the phase of demonstrating megawatt class turbines, but European companies have already done that in 2010s. So there's a lot of gap between the two. And we talked about LCOE regarding FOSW. And of course, FOSW compared to fixed type or other types would be more expensive. It's the same for oil and gas companies or projects as well. The farther you go out to the ocean, the more expensive it becomes or more costly it becomes. So FOSW, yes, it is more expensive. But to overcome that, we would have to conduct related R&Ds. As you can see here, I talked about future technologies in this slide, and the future technology is about how much we can reduce the cost and how safe can we make the system. That's the two key. Reducing the cost would also involve raising the performance. And first is FOSW and wind farm design. So when turbines become bigger to become 10 to 20 megawatt, their substructures or submersibles, the floatants would become the key. So the substructures and the turbines would have to be integrated in the design. And also, when creating massive farms, we need offshore substations or floating for offshore substations for FOSW, and to create technologies that can optimize operation of these substations. And next is dynamic cable. There's HV class dynamic cable being designed and manufactured. And certification of these cables is very important. And when they are actually installed out in the waters, we would also have to monitor them. That's the key. And there is transportation and installation part as well. So extra large installation vessel with larger crew is key here when turbines get bigger. But it needs to be bigger, but its movement needs to be smaller. And as far as operation and maintenance is concerned, there should be an operation optimization technology based on digital twin. And for mooring system and dynamic cable, we would have to monitor their stability. A technology that allows us to do so would have to be developed to build out our FOSW. So that's the end of my presentation. Thank you.
Thank you very much, Mr. Kyung-Hwan Kim, for this interesting presentation. And I think we have time for a short question for you and a short answer, hopefully. In your presentation, you talked a lot about the ambitious goals also when it comes to floating offshore wind. In the spirit of P4G, what role do you see for public-private partnerships in commercializing this technology and making it competitive to the other forms? You talked about the technology gap, for instance.
So this is a question that is not easy for me to provide an answer to. So today, the installation of offshore wind is being accelerated here in Korea. And to date, most of the projects were led by the government, but going forward, there is a great possibility that the private sector would take the lead. And against this backdrop, this is my own opinion, but the government would probably have to ease a lot of regulation in terms of policy and so on, especially regarding public acceptance. And that would allow the private sector to continue on its business at a very stable environment. And as far as technology is concerned, Korea's technology level falls behind that of foreign companies. And therefore, we would have to actively cooperate with European countries who have that capability to overcome the challenge. I hope that answered your question.
Thank you very much, Mr. Kyung-Hwan Kim. I know you are a researcher, but it was interesting to hear your take on it also. Now, here in Copenhagen, I have invited two of the previous speakers into the studio again. And first, I will ask a question to Ms. Rikke Winther Nørgaard from Aegir Insights about how do you see the role that floating offshore wind can play in Korea in the future?
Thanks. If we look at industrialized floater concept, we see a great opportunity for Korea to develop into a manufacturing hub in the region based on the existing skill capabilities. Other markets in the region, such as Japan and Vietnam and Taiwan, they also have great potential for developing floating offshore wind. But we see that Korea can actually take a first mover position and thereby take a clear position early on to be a floating hub.
Thank you very much. And I'd like to ask a question to one of the also previous speakers, Mr. Morten Hørmann from COVI. You had in your analysis some interesting figures for the possibility of creating new jobs and in the offshore wind project. Both the domestic and the partnership scenarios would create secure jobs, especially during construction and operation. Given the short-term supply chain constraints in a fully domestic scenario, is it likely at all that the partnership scenario will generate more domestic jobs due to the faster growth in installed capacity?
I think so, very much so, yes. As we heard Lisa, my colleague, say, the Korean supply chain is looking at something along the lines of a tenfold increase in capacity in order to meet the 2030 targets. And that kind of growth does not come overnight. And I think that the partnership scenario would be able to bridge the gap between the growth that is needed in the local supply chain and the growth that is needed to meet the policy targets. And the faster growth that the partnership scenario can provide will actually mean that they are creating more jobs in the short term than the domestic.
Okay, thank you very much. And thank you to both of you. We have now come to the end of today's event, but before we cut off, I would like to have or give the floor to Mr. Jacob Rasmussen from the Danish Embassy first, and after that to Her Excellence, the Dutch Ambassador to Korea, Joanne Dordevoort. So Jacob, first, the floor is yours.
Thank you, Finn. And thank you for a good event today with some very valuable insight, I would say, on the offshore business. So I hope that everybody that was listening today could find some inspiration in these speakers. And being in the spirit of P4G, I would also like to echo the partnership. I heard that word many times today. I see many people in the room here in Seoul, both Danish companies and Korean companies. So I think we had talked a lot about the challenges in Korea because, you know, the market started 10 years ago and there's 100 megawatt installed offshore wind today in Korea. So we still need the next stepping stone to reach our target. But I think we are getting there. And I was happy to hear also the Korea Energy Agency saying that they find the Danish experience valuable. Hopefully we can contribute to this permit and regulatory framework that is needed in Korea. And when we have that in place, I think we really need to look into the partnerships. It's not if we need to do partnerships, it's more like how we can do it. How can we build this win-win situation? And We from the embassies, of course, ready to stand by in the middle for any questions or follow up on the cost of energy study. I think it deserves to be read. You can download it as Lisa said on the COWI webpage, because it has a lot of valuable contribution to understand the market and engage further. So I hope we have inspired you to look into Korea as an offshore wind market and find these partnerships that are needed, both to lower the cost, but also to minimize the risk and make this a real scenario in the future. I think the dedication and vision is there, so we just need to follow through. So this was all that I had to say today, and I wish all of the online participants a good day, and also to you in Copenhagen. Thank you very much.
Thank you, Jacob. And now it gives me great pleasure to introduce our last speaker today, the Dutch ambassador to Korea, Her Excellence Joanne Doornewaard. Please, the floor is yours.
Thank you, Mr. Mortensen. Ladies and gentlemen, good morning in Europe and good afternoon here in Seoul and online, our participants. A very big thank you to our moderator and to all the speakers and to the organizers. And I would like to start my closing remarks for this event. My name is Joanne Doornewaard. I'm the ambassador of the Kingdom of the Netherlands. I would also like to mention here that I speak on behalf of my colleague Einar Jensen, the ambassador of Denmark in Korea. Because of personal circumstances, he unfortunately could not join us today. However, I know that he attaches great importance to the topic of offshore wind and that he's very sorry to miss this event. Let me look back at an interesting event today, at all the presentations and discussions. I must say I learned a lot this afternoon. We dived into the results of the study on the cost of offshore wind energy in Korea and the benefits of international partnerships. This study is a Danish-Dutch co-production, and I hope its findings will contribute to the development of offshore wind in Korea. We also heard insightful presentations on the approaches to manage the build-out of offshore wind nationwide. And I thought this was also very interesting given the need for national coordination of the energy transition. And we concluded with a presentation about the futuristic but very promising technology, floating offshore wind. And it's encouraging to see that Korea is really taking a lead in this. And all these presentations make one thing clear: offshore wind will be vital for the green development of Korea, the achievement of its climate ambitions, and the role of Korean industry in the future green economy. It's also clear that our countries, both governments and companies, have a lot to offer and have excellent partnership opportunities. And our embassies stand ready to make this cooperation happen. And we believe that the Korean target of 12 gigawatt offshore wind in 2030 is ambitious, but feasible. And partnering with Denmark and the Netherlands will make sure it can be done in time and at the lowest costs. For us in Europe, this international cooperation in offshore wind is already business as usual. Being neighbors around the North Sea, we work together closely in the build-out of our energy hub at sea. We saw some pictures of that already. The Netherlands and Denmark even signed an MOU on offshore wind cooperation last year. And the event today is a very good example of how this MOU plays out. In the North Sea, the Netherlands and Denmark made remarkable progress in only a few decades. Denmark was the first to build an offshore wind farm in 1991. And in 2017, the Netherlands was the first to realize offshore wind farms that do not require any subsidy. And I'm proud of this progress, and I'm glad that we had an opportunity to share our experiences here with Korea today. And last but not least, I want to recall that this event is organized on the occasion of P4G, on the P4G summit organized by Korea this weekend. The P4G, Partnering for the Global Goals on Green Growth in 2030, is a multilateral cooperation where Korea, Denmark, and the Netherlands play an important role. At the summit this Monday, the prime ministers of both our countries, the Netherlands and Denmark, will join live from our capitals. and we look forward to this very important online gathering. The P4G stands out as an initiative that focuses on partnerships, both international and between public and private partners. It was already mentioned here before. And I think that these partnerships are exactly what we need to make offshore wind a success worldwide. Today, we learned also that here in Korea, partnerships can be key to the development of offshore wind. So let's team up to realize 12 gigawatts offshore wind in Korea and beyond. Thank you. 감사합니다.
Thank you very much, Ambassador Dornevart. And let me echo the thanks that both you and Jacob Rasmussen spoke earlier to all the speakers today and to the participants. This was the last element of today's event, which we called Offshore Wind, 12 gigawatt and beyond. And as it was said, it was a P4G side event. I hope you all learned something and are inspired to discuss further. I've been told that the slides that have been presented today will be made available afterwards. We hope to see you all again during 2021, either online or even better, physically. All the organizations behind today's event hope to enter into further discussions on sharing experiences on how to accelerate solutions within offshore wind and the green transition. And we encourage all of you to reach out to the partners of today's event to learn more. Last but not least, on behalf of the organizers, a big thank you to all of you who joined us for this online event around the world, in Korea, in Europe, and for following and actively engaging in this webinar. I hope you feel inspired by what you learned today. Thank you and goodbye. Have a good evening. Have a good day.